School that nurtures your child's academic, spiritual, and personal growth, Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels: kindergarten, Pearson I Primary Certificate, secondary and Pearson IGCSE Certificate.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then, of course, in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in our learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Mohammed and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.
My name is Teacher Kasim. I'm a teacher of maths and chemistry. I teach at Andalusia Girls. Welcome to Andalusia Academy. Smart learning with Andalusia Academy on HorizonTV. Today, we shall discuss a chapter called Organic Chemistry, the introduction to organic chemistry. So we have the introduction. We have the introduction to organic chemistry. Organic chemistry is a chapter in chemistry that deals with the study of organic compounds. And as you all know, organic compounds can be straight chains or rings. And I will just give an example of organic compounds. For example, we have the alkanes, alkenes, and alkynes. So on the alkanes part, I'll begin with a chapter called, a subtopic or rather, called the hydrocarbons. So I'll begin with the hydrocarbons. Hydrocarbons are organic compounds that contain only carbon and hydrogen. Hydrocarbons are organic compounds that only contains carbon and hydrogen. I'll give examples of hydrocarbons. So we have these. These are organic compounds. Organic compounds that contains carbon and hydrogen only. When I talk about the hydrocarbons and say that they contain only carbon and hydrogen, alcohols cannot be called hydrocarbons because they have oxygen atom in them. So hydrocarbons must only contain carbon and hydrogen. I'll give examples of hydrocarbons. I'll start with the alkanes. So methane. Methane is a good example of an hydrocarbon, and you'll find that if I draw its displayed formula, it only shows carbon and hydrogen atoms in it. So I'll have the carbon, the central atom in this alkane is the carbon, and the carbon is at the center. Attached with a single covalent bonds are the hydrogen atoms, and methane is an example of an hydrocarbon that has 4 hydrogens and a carbon atom. I'll give you the second example, the ethane. Ethane is a good example of hydrocarbon because it contains carbon and hydrogen. I will proceed to write for you the displayed formula of the ethane, and you shall find that ethane will also be containing only carbon and hydrogen. So ethane stands for 2 carbon atoms. 2 carbon atoms. So carbon number 1 and carbon number 2. Then we have hydrogen, we have hydrogen, we have hydrogen, we have hydrogen, and we have hydrogen, and we have hydrogen. This is what we call the displayed formula of ethane. The displayed formula of ethane. We can as well note down the molecular formula of ethane. Molecular formula ethane has 2 carbons, so C2 and H6. So ethane has 2 carbons and 6 hydrogen. A good example of an hydrocarbon. I can give one last more example of hydrocarbons. I can give an example like the butane. The butane is an hydrocarbon as well that has 4 carbon atoms. So I can proceed to give you the displayed formula of the butane, and as well I can give you the molecular formula of butane. So butane has 4 carbon atoms. So carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So between these molecules, the atoms are joined to each other by a strong covalent bond. So these are the 4 carbons in butane. Then I proceed to attach hydrogen atoms. So every carbon atom must have 4 covalent bonds. And that's why I must ensure that as I place the hydrogen atoms in this chain, every carbon atom must have 4 covalent bonds. So the first carbon now is having the 4 covalent bonds. That is what you call the displayed formula of the butane. I also proceed to give you the molecular formula of the butane. So it has 4 carbons, and also it has 10 hydrogens. These are different examples of hydrocarbons. As we have said, hydrocarbons are molecules or organic compounds that contains only carbon and hydrogen. I wish to proceed and go to a different topic and talk about different formulas in organic chemistry. So the next part is on the types of formula. Types of formula in organic chemistry. Types of formula in organic chemistry. We have 4 different types of formulas in organic chemistry. We have the empirical formula, we have the displayed formula, we have the molecular formula, and we have the structural formulas. And if you understand one of them, it will be easy to understand the rest. Let me start with the empirical formula. Empirical formula shows the simplest whole number ratio of all the atoms that are there in a given compound. And what do I mean? I'll give an example of an empirical formula of a compound. For example, CH3 is the empirical formula of ethane. C3 is the empirical, CH3 or methyl. Methyl is the empirical formula of ethane. How? What do I mean? If you have the molecular formula of ethane, which is a C2H6, I'm supposed to simplify this because you have said that empirical formula shows the simplest whole number ratio of all the atoms that are there in a given molecule or a compound. So if I was to simplify this molecular formula of the ethane, then I'll be able to get the empirical formula of the ethane. So let me simplify. By 2, 1, by 2, 3. So I end up getting a CH3. This is called the methyl, the empirical formula of ethane. I'll give another example. If you have a compound, for example, like a C4H8, this is called a butene or butyl-1-ene. If I want to get the empirical formula of this butene, I need to simplify the atoms that are there. So, by 4, 1, by 4, 2. So the CH2, this is what we are calling the empirical formula of the butyl-1-ene. That's all on the empirical formula. Let me go to the second example of the formulas in organic compounds. And I will talk about the displayed formula. So the second one is the displayed formula shows actual number of atoms that are there in a compound, but those atoms must be shown by single covalent bonds. attached to each other. For example, the displayed formula shows all the atoms attached to each other by single covalent bonds. I'll give an example of a displayed formula. Let me pick an example. 1, ethane. Ethane is an example of an hydrocarbon that has 2 carbon atoms. I'm supposed to show how the atoms are attached to each other by single covalent bond. So, the displayed formula will be carbon, carbon, then hydrogen, 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 hydrogen. This is what you call the displayed formula of ethane. And as you can see, the carbon atoms are joined to each other by single covalent bonds. The hydrogen atoms as well, they are attached to the carbon atoms by single covalent bonds. So that is it on the displayed formula. One more example, I'll give you an example of the methane. Methane is a CH4. This is what you call the molecular formula of methane. Let me now proceed and give you the displayed formula of methane. So as you can see, we only have 1 carbon atom and 4 hydrogen atoms. So that is what we are calling the displayed formula of methane. So that is it on the displayed formula. Let me proceed and teach you on another type of molecular formula. Sorry, another type of formula in organic chemistry, and that is the molecular formula. Molecular formula shows the actual number. Molecular formula shows the actual number of each type of atom present. Understand my word? Understand the definition. The molecular formula shows the actual number of each type of atom present. And what do I mean? So it shows actual number of each The molecular formula shows the actual number of each type of an atom present. So I'll give an example. CH4 is the molecular formula of methane. CH4 is the molecular formula of methane. C2H6 is the molecular formula of ethane. C2H6 is the molecular formula of ethane. C4H8 is the molecular formula of but. 1-in is the molecular formula of but 1-in. And I can give you one more. The C5H12, for example, is the molecular formula of pentane. So these are different types of formulas that are available in organic chemistry. And I think now I'll narrow down my discussion and talk about a different thing. That is on the structural formula. There are 4 types of formulas: displayed formula, empirical formula, molecular formula, and structural formula. The last one is on the structural formula. So the fourth one is structural formula. The structural formula. And the structural formula shows how the atoms in a molecule are joined. The structural formula shows how the atoms in a molecule are joined. So if you understand the displayed formula, you can easily understand how to come up with the structural formula. So it shows how atoms in a given organic compound are joined. Shows how atoms in a given compound are joined. E.g., If you understand displayed formula, you can easily understand structural formula. So I'll give you the displayed formula of ethane and also give you its structural formula. So we have, this is a displayed, and here we have the structural. So ethane, for example, this is the displayed formula of ethane. So from the displayed formula, we can easily be able to draw the structural formula of a given compound. And what do? As we have said from our definition, it shows how atoms in a given organic compound are joined. So you can see this carbon atom is joined to 3 other hydrogen atoms. And this carbon atom is also joined to 3 other hydrogen atoms. So let me show. This is a CH3, CH3. That is a structural formula. That is a structural formula of ethane. One more example, I can give you the displayed formula of propane and be able to get the structural formula of propane. So that is the displayed formula of propane. 3 carbon atoms. Now let me get you the structural formula of the propane. So you just need to check how carbon atoms are joined to each other and how atoms are joined to each other. So we have CH3. This is the first attachment. Then in between you have a bond. We don't show the bond, so we only show this part. The CH2 is here. Then we show the last part, this one, which is the CH3, like that. That is the structural formula of the propane. Now we are going to a different thing. We are going to discuss a different stuff altogether on the alkanes. Alkanes are also part of organic compounds. And alkanes, they contain carbon atoms and hydrogen atoms are joined by single covalent bonds. Alkanes also, their name ends with -ane. From the word alkane, their names end with -ane. Alkanes have physical as well as chemical properties. We shall look at them in depth. So let me start by the part of the alkanes. So we shall say they are joined, or the atoms are joined by single covalent bonds. Their names end with -ane. Their names end with -ane. I'll give examples of alkanes. The first member of this group is called a methane. So examples. We have the methane. That's the first member, methane. You can see, meth stands for 1 carbon atom, and ane is the ending of all the alkanes. So if I can draw both the displayed formula, structural formula, and the empirical formula. But I will just need to draw the molecular formula for each. So methane is 1 carbon, CH4, and it has 4 hydrogens. Then I can also write the word ethane is second member. Ethane is the second member, and ethane has 2 carbon atoms and single covalent bonds that are joining the atoms. So C2 and H6. These are members of the homologous series alkanes. So we have the propane. The third member is the propane, which shows 3 carbon atoms and 8 hydrogen atoms. That's the third member, the propane. The fourth member is the butane. Butane shows 4 carbons and 10 hydrogens. This formula that I'm giving here, there's what you call a general formula for all the alkanes. They are all obeying general formula as CnH2n plus 2. All the alkanes, as you write down their molecular formula, they must obey the general formula CnH2n plus 2, whereby the N stands for the number of carbon atoms. So if a compound, for example, is the pentane, and we see that the pentane has 5 carbon atoms, so we use this formula C5, that one, then we shall have the H, then 2 times 5 plus 2, which becomes a C5H12. So this is what we are calling general formula. It's an easier way of deriving the molecular formula of a given hydrocarbon. So the sixth member is the hexane. From the word hexane, hex stands for 6 carbon atoms. So I shall have a C6 from the general formula. N stands for the 6. Then H, 2 times 6 plus 2. So I shall have a C6H14. So these are just but examples of members of the homologous series alkanes. So I would want to narrow down to the chemical properties before I go to the physical properties, the chemical properties of alkanes. So there are different chemical properties of alkanes, and I'll begin with the first one, combustion. Combustion is eating of any substance in oxygen. So alkanes undergoes combustion. When alkanes are heated in excess oxygen or excess supply of oxygen, we form water, carbon dioxide, and energy. So those are the products of the complete combustion of alkanes. Also, when the alkanes are burned in limited supply or less supply of oxygen, we form different products. Sometimes we can form carbon monoxide, which is a very poisonous gas. We can form water, energy, and sometimes we form carbon. So, when they burn in excess oxygen, we form water and carbon dioxide. Let me repeat. When alkanes burn in excess oxygen, they form water and carbon dioxide, and sometimes energy. When they burn in less supply of oxygen, we form carbon monoxide, carbon, water, and sometimes energy is released. So I'll proceed to give you what we call a chemical equation. A chemical equation that shows the reactants and the products when these hydrocarbons burns in oxygen. The first example, I'll use the example methane, which is CH4 plus oxygen. We form CO2 plus water. This one is a gas, and liquid. So these are the reactants. When you burn methane in oxygen, excess oxygen, it has to be excess. The oxygen must be excess. You form water and carbon dioxide. This equation is not valid until it is balanced. So let's balance the chemical equation. We have one carbon atom on the left, and we have one carbon atom on the right. Carbons are balanced. We have 4 hydrogens on the reactant side, and we have 2 hydrogens on the product side. So I'm supposed to put a 2 at the back to balance the number of hydrogen atoms on the product side. So when you look at this, we have 4 hydrogens, and we have 2 oxygens here, and we have 2 oxygens here. So in that case, oxygens are not balanced because we have 4 oxygens on the product side, and we have 2 oxygens on the reactant side. So I must put a 2 at the back to balance the number of oxygen atoms. When you look at the equation, now it is a fully balanced stoichiometric equation. I'll go to a different example. For example, of the ethane. When you burn ethane in excess oxygen, we form also water and carbon dioxide. We can as well balance this equation. We have 2 carbons here and we have 1 carbon here. So we need to add a 2 here to have 2 carbons. We will have the easier way to balance this equation. You can start by putting a 2 at the back. If you put a 2 at the back there, we have 4 carbons. So here we also put a 4 to show carbons are 4. We have 12 hydrogens on this side. These are 6 times 2 is 12. So you need to put a 6 at the back to have a total of 6 hydrogens also on the side of the products. Now, oxygen is not balanced. And how do you balance the oxygen? This side we have how many oxygens? This is 6 plus 8. That gives a total of 14. That gives a total of 14 oxygen. So we have to put a 7 at the back to balance the number of oxygen atoms. So these are balanced equations for the combustion of hydrocarbons in oxygen. So I'll go to a different thing on the products of the incomplete combustion of hydrocarbons. So as we said before, the incomplete combustion of hydrocarbons forms or produces water, carbon monoxide, carbon, and sometimes energy is released. In our next topic, we shall learn about how to write down correctly balanced stoichiometric equation that shows the products of the incomplete combustion of hydrocarbons. Thereafter, we shall also discuss about the substitution reactions. The substitution reactions in alkanes, the reactions that involves or take place when there is an involvement of UV light. My name is Jakasim. I've been taking you through the organic chemistry topic. See you next time. Thank you so much.